In this video, we are going to solve 30 questions under the integrations of trigonometric functions. So let's come to the first one. Integrate tan x exponent 5 sec x dx. Then the B part is integrate cos x divided by square root of sine x dx. So let's start with the A part, which says that we should integrate tan x exponent 5 sec x dx. So I want to rewrite the integral as integral of, I want to pull out one tan x. So it becomes tan x exponent 4, then tan x sec x. So let's put this one in brackets, dx. But we know that from trig identities, 1 plus tan squared x is equal to sec squared x. So if we make tan squared x the subject, it implies that tan squared x is equal to sec squared x minus 1. So I can then write this integral as integral of tan squared x all squared, then times tan x sec x dx. So now let's replace this tan squared x with all of this. So this becomes integral of, into bracket, sec squared x minus 1 all squared times tan x sec x dx. Now let's expand this. This becomes integral of sec x squared all squared is sec exponent 4. So here sec x exponent 4, then minus 2 sec squared x, then plus 1, then times tan x sec x dx. So from here, let us expand all of the integral. It becomes integral of sec x exponent 4, then times tan x sec x dx, then minus 2 integral of sec squared x, then tan x sec x dx, then plus integral of tan x sec x dx. So what we'll do is that we'll then take these individual integrals and evaluate them separately. So let's come to the first one, which is integral of sec x exponent 4, then times tan x sec x dx. Now let's let a to be equal to sec x. So the a is equal to, if you differentiate sec x, you get tan x sec x dx. So this implies that dx is equal to dA divided by tan x sec x. So we'll then take all of this and dump it into this integral. So the integral becomes integral of sec x exponent 4 becomes a exponent 4, and then tan x sec x times dx is now dA divided by tan x sec x. So this tan x and sec x can cancel. So the integral becomes integral of a exponent 4 dA, and that is equal to 1 over 5 a exponent 5. But I'll add a constant of integration when I'm done with all of the integrals. So, but we know that a is sec x, so this is equal to 1 over 5 sec x exponent 5. So let me rewrite it here. This is equal to 1 over 5. So let's cancel this. Sec x exponent 5. Now let's evaluate this one, which is this integral of 2 sec squared x times x sec x dx. So it's still the same thing. We will still use all the processes that we did here. So we'll do the substitution a cos sec x. So we've already done it here. So this will be 2 integral of sec squared x becomes a squared using the substitution that we did here. And then times dx, and then dx is dA divided by tan x sec x. So but this is, there is a tan x, so times tan x sec x here. So that and this one will cancel. So this is equal to integral of 2a squared dA, and that's equal to 2 over 3 a exponent 3, and that is equal to 2 over 3 sec x exponent 3. And then now let's do the last one, which is integral of tan x sec x dx. So you see that all of this is dA. So this is equal to integral of dA, and that is equal to a, but a is sec x, so this one will give us sec x, and therefore integral of tan x exponent 5 sec x is equal to, sorry, there's a dx here, is equal to this integral, which evaluates to 1 over 5 sec x exponent 5, and write this well. And then this one, which is minus 2 over 3 sec x exponent 3, and plus this last one, so plus sec x. Then now let's come to the b part. The b part says we should integrate cos x divided by square root of sine x dx. So let's let a to be equal to sine x. So the a is equal to cos x dx. So this implies that dx is equal to dA over cos x, and therefore the integral becomes integral of cos x divided by square root of sine x times dx, and dx is dA, sorry, the integral becomes integral of cos x divided by square root of sine x is now a, so square root of a times dx, and dx is dA over cos x. So this cos and cos will cancel out, so we get integral of 1 over square root of a is the same as a exponent negative half dA, and that will give us 2a exponent half plus c. So now a exponent half is square root of a, and then a sine x, so all of this we evaluate to 2 root sine x plus c. So we are supposed to evaluate integral from minus half to half of 1 over square root of 1 minus x squared dx. So let's let x to be equal to cos phi. So it implies that dx is equal to minus sine phi d phi. So now if x is equal to half, see that phi is cos inverse of half, and cos inverse of half is pi over 3. So phi is equal to pi over 3, and therefore this integral becomes integral of minus pi over 3 to pi over 3, then 1 divided by square root of 1 minus, now x is cos phi, so x squared becomes cos squared phi, then times dx, and dx is minus sine phi d phi. So let me pull the minus out of the integral. So this becomes minus integral of minus pi over 3 to pi over 3. Then 1 divided by square root of 1 minus cos squared phi is sine phi. Then here we pull out the minus, so it will be left with times sine phi d phi. So this sine phi d phi can cancel this one out. So we are going to be left with integral from minus pi over 3 to pi over 3 of d phi. And if you integrate d phi, you get phi evaluated at minus pi over 3 to pi over 3. But there is a minus here which I forgot. So here will give us minus 5. So let's put in the limits of integration. So it will become minus into bracket pi over 3 minus pi over 3. And this one, the bracket, minus pi over 3 minus pi over 3 is minus into bracket 2 pi over 3. Sorry. So the final answer is going to be minus 2 pi over 3. Now this is a negative angle. So to convert it to a positive angle, we will subtract it. We will add pi to it. So this is the same as saying minus 2 pi over 3 plus pi, and that will give us pi over 3. Find the exact value of the given quantity a sec into bracket sine inverse of minus 3 over 4, and then the b part is sine into bracket 2 cos inverse of 3 over 5. So this is a case of the special triangles. Now let me draw one of the special triangles. We know that the sum of the angles in a right angle triangle is pi, or 180 degrees. So in this case, we know that to be able to find the angle here is going to be sine inverse of x. And then so if the angle here is sine inverse of x, then the angle here too could also be cos inverse of x. So this is the case of the special triangle. So that now if we put 1 here and then we put x here, based on Pythagoras theorem, then here is going to be square root of 1 squared minus x squared, and 1 squared is 1, so it's going to give us square root of 1 minus x squared. Based on this, we can write the value for sec of sine inverse. So sec of sine inverse of x is equal to, now sec is 1 over cos, and cos is adjacent over hypotenuse. So since it is now 1 over cos, then it's going to give us hypotenuse over adjacent. And since it's hypotenuse over adjacent, it's going to give us 1 divided by square root of 1 minus x squared. So now sec of sine inverse of minus 3 over 4, it simply means that wherever we see x in this equation, we should replace it by minus 3 over 4. So here becomes 1 divided by square root of 1 minus into bracket 1 minus 3 over 4 squared. So this is equal to 1 divided by square root of 1 minus 9 over 16. So this is equal to 1 divided by square root of 7 over 16. And then if you do all of this, it will give us 4 root 7 divided by 7. The b part is sine of cos inverse of 3 over 5. So with the special angles too, we have the special angle for the cos inverse. So you see that this is cos inverse. So we can write the value for sine of cos inverse of x. So now sine is opposite over hypotenuse. So sine of the cos inverse of x is going to give us, so we are here, opposite. The opposite is square root of 1 minus x squared divided by hypotenuse. Hypotenuse is 1. So sine of cos inverse of x is equal to square root of 1 minus x squared. But sorry, there is a 2 here. So sorry, let me bring the 2. So because of this 2, you cannot just evaluate this straight away. So we can rewrite this as sine of, since it is 2, there can be cos inverse of 3 over 5 plus cos inverse of 3 over 5. Bracket close. So let me use a big bracket. So that based on sine of A plus B, which is equal to sine A cos B, then plus cos A, sorry, let me just say sine B cos A. So now this is equal to, so using that in this expansion is going to give us sine, so all of A, this is all of A, cos inverse of 3 over 5, and all of B is also cos inverse of 3 over 5. So it's going to give us sine cos inverse of 3 over 5, then cos inverse of 3 over 5, then plus sine inverse, so sine B, so sine of cos inverse of 3 over 5, then times cos of cos inverse of 3 over 5. So this is equal to, now cos of cos inverse of A is equal to A, and therefore here is cos of cos inverse of 3 over 5, so it's 3 over 5, then sine of cos inverse of 3 over 5, then plus, here it is the same thing, cos of cos inverse of 3 over 5 is 3 over 5, then sine of cos inverse of 3 over 5. So at the end of the day, it's going to give us 2 times of 3 over 5, which is the same as 6 over 5 sine, sorry, let me rewrite it here. So this is equal to 6 over 5 sine of cos inverse of 3 over 5. So you see that this looks like this. So we can now use the identity. We said that sine of cos inverse of x is equal to square root of 1 minus x squared from the special triangles. So this will give us 6 over 5, then times, so wherever we see x here, we replace it by 3 over 5. So times square root of 1 minus 3 over 5 all squared. So this is equal to 6 over 5, then times square root of 1 minus 9 over 25. So this is equal to 6 over 5 times square root of 16 over 25. And this is equal to 6 over 5 times root 16 is 4 divided by root 25 is 5, and that is equal to 24 over 25. So we are supposed to evaluate cos of tan inverse of x, tan of cos inverse of x, sine of sec inverse of x, and cot of sec inverse of x. So all these are the case of the special triangles. So let me draw the special triangles here. So the first one is what we saw, I illustrated based on the previous example that we saw. And here is 1x, then square root of 1 minus x squared. Then the second special triangle is the tan one, so it's this one. Here is square root of 1 plus x squared. Then here is x, and here is 1. Then the last of the special triangles is this special triangle. Yes, x 1, then square root of x squared minus 1. So now the first one is cos of tan inverse of x. So this is tan inverse. Cos, that is, so let's use the SOHCAHTOA. So car, then toa. So cos is adjacent over hypotenuse. So tan inverse of x is here. Adjacent is 1 and then hypotenuse. So cos of tan inverse of x is equal to the adjacent, which is 1, divided by the hypotenuse, which is square root of 1 plus x squared. So this is the A part. Let's come to the B part. The B is tan of cos inverse of x. Now tan is opposite over adjacent. This is cos inverse. So the opposite here is square root of 1 minus x squared. Then over adjacent. And then the adjacent is x, so divided by x. Then let's come to the C part. The C is sine of sec inverse of x. So this is sec inverse. Sine is opposite over hypotenuse. So the opposite here is square root of x squared minus 1 divided by the hypotenuse, which is x. So it is cot of sec inverse of x. So this is the sec inverse of x. And then the cot is adjacent over opposite. So the adjacent is 1 and the opposite is square root of x squared minus 1. So find integral of, into bracket, 1 divided by 2 square root of 1 minus x squared minus 3 divided by 1 plus x squared dx. So this, let me break the integral into 2 so that we'll get integral of 1 divided by 2 square root of 1 minus x squared, then minus integral of, there's a dx here, integral of 3 divided by 1 plus x squared dx. So this is equal to, now let's factorize 1 over 2 out. So if we factorize 1 over 2 out, it becomes integral of 1 divided by square root of 1 minus x squared dx. Then minus, let's factorize 3 out. 3 integral of 1 divided by 1 plus x squared dx. Now, what is the differentiation? If we differentiate sine inverse of x, what do we get? We get 1 divided by square root of 1 minus x squared. So you see that this one is sine inverse of x. And then if you differentiate tan inverse of x, it's equal to 1 divided by 1 plus x squared. So this one is tan inverse of x. And therefore the integral becomes half of sine inverse of x, minus 3 tan inverse of x plus c. So this integral is equal to half of sine inverse of x, then minus 3 tan inverse of x plus c. So we are supposed to evaluate this one too, which is integral of, into bracket, 4 divided by x square root of x squared minus 1, then plus 1 plus x cubed divided by 1 plus x squared, all into bracket, then dx. So let's do this. Let's rewrite this as, I'm breaking the integral into 2 so that we'll get integral of 4 divided by x square root of x squared minus 1 dx, then plus integral of 1 plus x cubed divided by 1 plus x squared dx. So this becomes integral of 4 divided by x square root of x squared minus 1, then plus integral of, I want to break this into 2, 1 divided by 1 plus x squared, then plus, I want to do this like this, put this into bracket, x plus x cubed, then dx. So this becomes, I'm factorizing 4 out, 4 integral of 1 divided by x square root of x squared minus 1 dx. Then I'm breaking this integral into 2, plus integral of 1 divided by 1 plus x squared dx, then plus x cubed. So integral of divided by 1 plus x squared dx. So this is equal to 4 integral of 1 divided by x square root of x squared minus 1, then plus 1 integral of, so dx, integral of 1 divided by 1 plus x squared dx. Then I'm factorizing x out of this, so plus integral of x times, if you factorize x, you will have 1 plus x squared divided by 1 plus x squared dx. So this and this one will cancel, so we'll be left with 4 integral of 1 divided by x square root of x squared minus 1, then plus integral of 1 divided by 1 plus x squared, sorry, there's a dx here, then plus integral of x dx. If you differentiate d dx of sec inverse of x, it's equal to 1 divided by x square root of x squared minus 1. And then if you differentiate tan inverse of x, it's equal to 1 divided by 1 plus x squared. So you can see that this, all of this is sec inverse and all of this is tan inverse, and therefore this is equal to 4 sec inverse of x, then plus tan inverse of x. Then if you integrate x, you get half of x squared, then plus. This one too, we are supposed to evaluate integral of dx divided by square root of 1 minus 4x squared. So now let's let x to be equal to sine phi. So dx is equal to cos phi d phi. Sorry, I want to put half here, so dx is going to give us half. Now I'm putting the half such that when we square this, we will get divided by 4, and that divided by 4 will kill this 4. So x squared is equal to 1 over 4 sine squared phi. So integral of dx divided by square root of 1 minus 4x squared is equal to integral of dx. Dx is now half, so half cos phi d phi divided by square root of 1 minus 4 times 1 over 4, then the x squared is sine squared phi, so sine squared phi. So this is equal to, now I'm pulling half out, half integral of cos phi d phi divided by square root of 1 minus sine squared phi. So this is equal to half of integral of cos phi d phi divided by square root of 1 minus sine squared phi is cos phi. So this cos phi and cos phi cancels out. This is equal to half of integral of d phi, and that's equal to half of phi plus c. Nonetheless, we said that x is equal to sine phi, so let me write it here. X is equal to sine phi, so sorry, half sine phi. So it implies that phi is equal to sine inverse of 2x, and therefore this is equal to half of sine inverse of 2x and plus c. So in this example, we are supposed to evaluate integral of exponent x divided by 1 plus exponent 2x dx. So let's let x to be equal to natural log of absolute value of tan a. So dx in this case is equal to, if you differentiate tan, you are going to get sec squared a, but you need to divide it by tan a because it's the natural log and dA. So the integral, which is integral of exponent x divided by 1 plus exponent 2x, is equal to integral of exponent x is now natural log of absolute value of tan a, then divided by 1 plus exponent 2 natural log of the absolute value of tan a. Then here is now dx, but dx is sec squared a divided by tan a dA. But then we know that exponent natural log of x is equal to x. So this is equal to integral of exponent natural log of, so this one will give us tan a, then times sec squared a divided by tan a dA. All of this divided by this one will give us 1 plus tan squared a, so that this tan a and this tan a can cancel out. So the integral becomes integral of sec squared a dA divided by 1 plus tan squared a. Nonetheless, from trigonometric identities, 1 plus tan squared a is equal to sec squared a. Therefore, this integral becomes integral of sec squared a dA divided by sec squared a. So this sec squared a and sec squared a will cancel. So the integral becomes integral of dA, which is equal to a plus c. But we said that x is equal to natural log of the absolute value of tan a. So we are going to find a from here. So this means that exponent x is equal to tan a, and therefore a is equal to tan inverse of exponent x. So the integral of exponent x divided by 1 plus exponent 2x dx is equal to tan inverse of exponent x plus c. Evaluate the integral of sec squared x dx divided by square root of 1 minus tan squared x. Let's let a to be equal to tan x. So dA is equal to sec squared x dx. So this implies that dx is equal to dA divided by sec squared x. So this integral becomes integral of now sec squared x, then the dx is dA divided by sec squared x, then divided by square root of 1 minus tan squared. Now a is equal to tan x, so tan squared x is a squared. So this sec squared x and sec squared x will cancel. So the integral becomes integral of dA divided by square root of 1 minus a squared. Now, this is sine inverse of x. d dx of sine inverse of x is equal to 1 divided by square root of 1 minus x squared. So, integral of dA divided by square root of 1 minus a squared is equal to sine inverse of a. Nonetheless, we said that a is equal to tan x of sec squared x dx divided by square root of 1 minus tan squared x is equal to sine inverse of tan x plus c. So integrate integral of sine theta divided by cos squared theta plus 1 d theta. So let's let a to be equal to cos theta. So dA is equal to minus sine theta d theta. So it implies that d theta is equal to minus dA divided by sine theta. So this integral of sine theta divided by cos squared theta plus 1 d theta is equal to integral of sine theta times dA, which is times d theta, which is minus dA over sine theta, then divided by cos squared theta, but a is cos theta, so cos squared theta is a squared plus 1. So that this sine theta and sine theta can cancel out. So we left pulling this minus out. Minus then dA divided by 1 plus a squared. Now, d dx of tan inverse of x is equal to 1 divided by 1 plus x squared. So integral of this is minus tan inverse of a plus c. Nonetheless, a is equal to cos theta. So this is equal to minus tan inverse of cos theta plus c. Integrate dx over 5 plus x squared. So let x to be equal to square root of 5 tan theta. Now, the reason why we are using square root of 5 is because so that when we square it, we will get 5 here, so that we can factorize this 5 out. So x squared is equal to 5 tan squared theta. And then dx is equal to root 5, then sec squared theta. So the integral of dx divided by 5 plus x squared is equal to integral of dx square root of 5, then sec squared theta divided by 5 plus x squared, which is 5 tan squared theta. So I'm pulling this root 5 out, so root 5, then integral of there is dx, so there is a d theta here, so here is supposed to be d theta. So sec squared theta d theta, and divided by, I'm pulling out 5 here, so 5 times 1 plus tan squared theta. So this is equal to square root of 5 divided by 5 integral of sec squared theta d theta, then divided by 1 plus tan squared theta. I will know that from trig identities 1 plus tan square theta is equal to sec square theta. So this is equal to square root of 5 divided by 5. Integral of sec square theta d theta divided by sec square theta. So these two will cancel out. So we'll be left with square root of 5 divided by 5 integral of d theta, and that is equal to square root of 5 divided by 5 theta plus c. But we know that x is equal to square root of 5 tan theta. So x divided by root 5 is equal to tan theta. So x root 5 divided by 5 is equal to tan theta. Therefore theta is equal to tan inverse of x root 5 divided by 5. So therefore integral of dx divided by 5 plus x squared is equal to root 5 over 5. Then theta is equal to tan inverse of x root 5 over 5 and plus c, a constant of integration. So we are supposed to integrate dx divided by x root x squared minus pi. So let's let x to be equal to root pi sec a. Now the reason why we are using root pi is that so that when we square x, we can get pi here and factorize this pi out. So that x squared is equal to pi sec squared a. Now dx is equal to root pi. And if you differentiate sec a, you are going to get tan a sec a dA. So this implies that integral of dx divided by x square root of x squared minus pi is equal to integral of dx is square root of pi tan a sec a dA, and divided by x is square root of pi sec a, then square root of x squared, which is pi, then sec squared sec squared a, then minus pi. So this pi and this pi can cancel out, and this sec a and sec a can cancel out. So we are left with integral of tan a dA divided by square root of pi sec squared a minus pi. So you can factorize pi out, and if you factorize pi out, you get 1 over square root of pi integral of tan a dA divided by square root of sec squared a minus 1. Now from trig identities, 1 plus tan squared a is equal to sec squared a. So tan squared a is equal to sec squared a minus 1. So all of this becomes 1 over root pi integral of tan a dA divided by, now tan squared a, all of this is tan squared a, so here is going to give us tan a, so that this tan a and tan a can cancel. Below 1 divided by root pi integral of dA, this is equal to 1 over square root of pi a plus c. Nonetheless, x is equal to root pi sec a. So a is equal to sec inverse of x over root pi. So this is equal to 1 over root pi sec inverse of x over root pi, then plus c, a constant of integration.